So we were looking at what happens when you have one angle and you were trying to make them look as different as possible. So this is just one example, but notice I've got this angle is 45 degrees on both of them. This triangle is an acute triangle, whereas this triangle is an obtuse triangle. So these two are not the same shape. They're also not the same size, which means that these would not be similar, right? So I need more than just one angle to tell if they are similar. Okay? So then we looked at, well, what happens when we have two angles? Well, if we have two angles, we've got one is 45 and one is 30. Okay, so notice here, if I find this angle to determine what that angle is, since we have two of them, I would do 180 minus the 45 minus the 30. So if we do 180 minus the 45 minus the 30, that gives us 105, which means both of these will be 105 because these were both 45 and 30. So each one of those is 105. Now, it may take a little bit of twisting and turning to get and enlarging to get this one to match this one. Let's see if I can make it do that. Oh, it doesn't do the shape. Okay. So I don't have it so that it's dynamic, but I could make this so that it's larger and tilt it a little bit so that it's this way, so that then I can turn it into this one, right? So they will end up being the same shape, but just different sizes. So it looks like two angles work. So then it said, well, what if we add one of the sides to be the corresponding sides to be 2 and 6. So in my case, we could call this one 2 and this one 6. So again, I'm going to erase the 105s for the moment because we've just got these two angles. So here, notice we would have our two angles and then a side, but we still have that these are similar because I could move this into being this shape regardless of what side lengths these are. I could also change my 2 and my 6, so maybe this was 2 and this was 6, right? And I could do that same thing where I change this shape into this one right here just by turning it a little bit this way and then enlarging it, regardless of the fact that 2 and 6 are here. Okay? So notice on that last one we had angle, angle, side. This would be angle, angle, side. On this one we have angle, side, angle, angle, side, angle. I also could do angle, side, angle, 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 side. Oh, those are the two that we have, right? So regardless of if we have sides or not, anytime you have two angles, you know that those are congruent. So if we go to our notes, we have this theorem that's called the angle-angle similarity postulate. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And part of that is because when you know two of them, then you know the third one as well. So if JKL, so JKL is congruent to, so that would be this one right here, so XYZ, so angle XYZ, so we know JKL and XYZ, so those two are congruent, and KJL, so KJL is this one, and YXZ is this one. So if we know those two are congruent, then we can tell that these triangles are similar. Now notice J corresponds to X, K corresponds to Y, right? Those are the same. And L corresponds to Z. L corresponds to Z, so these two are the same. And then J corresponded to X, which I hadn't pointed to. Okay. Now, we have one that we didn't look at, where we've got we've got two that we didn't look at, where you've got more than one side. So here we've got side, 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 and then we also have side, angle, side. Okay. So side, side, side works, which should make sense to you if all three of these are proportional. Then our angles would have to be fixed based on the fact of our side lengths, right? If you have 3 crayons, 3 pens, 3 markers, 3 straws, 3 of anything that makes a line, and you put them so that they are proportional parts, and you try to make different size angles, it's not going to work. Okay? So when we've got side, 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 that also gives us similar triangles. So we've got JK. So notice, and now on our pictures, you can't put congruencies because they're not the same. So I like to put shapes so that I can visually see that they're corresponding. So JK is this one. So JK corresponds to XY. And KL, so KL is this one, so I'm going to do a triangle, corresponds to YZ, so it corresponds to this one. And ZX, I'm going to do a square. Oh, ZX corresponds to LJ, LJ to ZX, right? So you've got, we're always going from the little one to the big one. These correspond, and those correspond, which means that then we know that these triangles are similar. And again, it's got the corresponding parts. We also have side angle side. Okay, so if we had taken just one angle, but we knew these two sides were proportional, then I would have to have, let's see here, draw a slightly better picture. So this is 45 degrees, but these sides have to be proportional. So if I say this one's 4, then that one's 2, and this one's 6, then that one's 3, right? Then I'll create a triangle that looks similar to this one where the sides are matching to be proportional, and then you've got an angle in between them that is the same. Okay? That will force it to be the same. Or to be not the same, to be same shape but a different size. Okay? So same kind of thing that you have here, you only have 2 of the 3 proportions. It's important to note that on side angle side that it's your angle in the middle in between the 2 sides that has to be there. Remember, your order matters. So again, you want to be careful when you're writing your similarity state that the similarity statement that the corresponding parts are matching. So let's try some examples of these.